Okay, so we did the graphing of the function and we did the graphing of a piecewise function. And let me do piecewise function one more time. Okay, you will be asked to graph the piecewise function on your next test, which is before our spring break. Okay, so let's do one more graphing piecewise function. Let's graph piecewise function. Then after that we'll continue our section 2.4. Okay, let me take an example from our homework. Okay, this is your homework 53. Okay, so let me do 53 for you. Okay, this is 53 from your exercise. Okay, so here we have a piecewise function f of x equals to x squared if our x is greater than equals to -1 and less than equals to 2. Okay, the same f of x is equals to -2 if our input x is greater than 2, less than equals to 3, and the function is x plus 1 if our input x is greater than 3. So this is the piecewise function that we have here, and we need to graph this function. So we have three different inputs here. So the very first is our x, which is greater than equals to -1 and less than equals to 2. We have the next input set of domain x greater than 2 and less than equals to 3. And the last one is our input is greater than 3. So here for different input we have a different output. Okay, so we're going to have a three different graph here. For each set of input we're going to have a different graph, and the reason is that for each set of input we have a different output. So this is the input for this first, this is the output for the first input, this is the output for the second input, and this is the output for the third output. So here we're going to have a different graph for each of these set of inputs. Okay, so here what we do here is that we have the x-axis, y-axis. Okay, so we have x-axis, we have y-axis, we have origin. Now let's take the very first input. The very first set of input is our x is greater than equals to -1 and less than equals to 2. Where do we find that on our coordinate system? So let's say we have 2 here and we have -1 here. Okay, so when your x is greater than equals to -1, less than equals to 2, what is f of x equals to? That is x squared, right? So our f of x is x squared. So let's make a table for this function. Okay, you can choose any x, and that x has to be greater than equals to -1 and less than equals to 2. Okay, and we get output here, f of x. Okay, now what kind of input we can choose for this function? Okay, we have it. Okay, if can you choose one x for this function? What x can you choose? 2. Okay, so if x is 2, so let's choose x equals to 2. What will be the output? So you substitute in this function. So you substitute for x. So we have 2 squared, that is 4. Okay. Okay, next Peter, can you choose one more one input for this function? 1. Okay, yes, we can choose 1. Okay, when x is equals to 1, what would be f of x? It's 1 squared, right? And which is equals to 1. Now this is a quadratic function, so we need at least like 5 points. Okay, so let's choose, can we choose -1? Yes, so if x is -1, then our f of x is, you substitute -1 for every x. So -1 square is +1. Okay, so let me choose Okay, so we have -1, we have, okay, we can choose 0. So if x is 0, we have 0 square, that is 0. Okay, so we did choose -1, 0. Okay, this should be enough. Now let's go ahead and plot these points. So when x, so we have 2, 4. So we have 2. So let's say this is 1, 2, 3, 4. So we have 2, 4. Okay, then we have 1, 1. So let's say this is 1. So we have 1, 1. So we have -1, 1. Okay, this -1 is too far. Okay, just let me try to have a even here. So this is -1, -2. So we have -1, 1. So this is -1, 1. And we have 0, 0. So this is 0, 0. Okay. Now let's connect these points. We get a graph. Now how far can we go on the left? How far can we go on the left? Can we extend this graph on the left? No. Okay, yes, it's not possible because our input is greater than or equals to -1. So we have a closed circle here at -1. Okay, so we have a closed circle. And what about on the right? Can we extend the graph on the right? No, that's true because x is less than or equals to 2. And at 2 we have equals to here, so we're gonna have a closed circle. So this is a graph for the first part. Okay, now let's have x equals to greater than 2. So when x is greater than 2 and less than or equals to 3, what is our f of x equals to? So when our x is greater than 2 and less than or equals to 3, what is f of x equals to? F of x equals to -2, right? So we have f of x equals to -2. So we make a table. So you make a table here. So we have x, we have f of x. Now what kind of number we are allowed to choose? Our x has to be greater than 2 and less than or equals to 3. Now can we choose 2 here? Are we allowed to choose 2 for x? No. What about 2.5? We can choose 2.5, right? So when x is equals to 2.5, what is f of x equals to? -2. So we substitute this x equals to 2.5 in every x, but we don't have x on the right side. Okay, so it means this is a constant function and every time we get the same output. So we have -2. When you choose, okay, what about 3? Can we choose 3? So when x is 3, our output is always same because this is a constant function, -2. Now let's plot these 2 points on the graph. So we have 2.5 and -2. So this is 3. So 2.5, so is here, 2.5 here, and -2. So this is -1, -2. So we have 2.5 and -2. This is the point. Next 3, -2. So we have 3, -2. Now we connect these 2 points, we get a graph. Okay, now how far can we go this graph on the left side? Up to 2. Now at 2, what are we going to have? Open circle. So you can extend this graph all the way up to 2 and you're going to have an open circle here. Now what about on the right? How far can we extend this graph on the right? Just at 3, and we're going to have a closed circle here. So we have a closed circle at 3. So this is a graph for the next part. So we have one more. So when our x is greater than 3, our function f of x is given by x plus 1. So we have x plus 1. So let's make a table. So you can choose any x which is greater than 3. Okay, you can choose any number. So we can choose 4. So when x is 4, what is our f of x? You substitute here 4 plus 1, 5. When you have x equals to 5, you get 6. This is a linear, we get a straight line. 2 points is enough. So let's substitute 4, 5. Okay, so this is 4, this is 5, okay, and we need up to 5, 6. So 1, 2, 3, 4, 5, 6. So when is 4, we have 5. Okay, so this is 4 and this is 5 over here. and when it's 5 it's 6. Okay, so we connect these 2 points, we get a graph. Now how far can we extend this graph on the left side? Up to the 3. And what happens at 3? So at 3 we're going to have an open circle. So you extend up to 3 and you're going to have an open circle. Now what about on the right side? How far can we go on the right side? Yes, we can extend all the way to the infinity. So it's not possible to draw, but you can give here arrowhead. It means if you have an arrowhead, you can extend your graph on the right side. Okay, so this is a graph for this piecewise function. Okay, you will have this question, you will be asked to graph this piecewise function. Okay, all right, do you have any question? Okay, if so, now let's go ahead and continue our remaining portion from section 2.4. Okay, the next here we have the vertical line test. So the next is vertical line test, and this test, we use this vertical line test to check whether our given graph is a function or not. So you have a graph and you will be asked whether that graph is a function or not. Every graph is not a function, okay? And we have this vertical line test. And vertical line test, what it does is that how we do this is that we draw a vertical line, okay, on the graph. So we draw a vertical line, and if every vertical line crosses the graph exactly at one point, then your graph is a function. So you draw a vertical line, you can draw anywhere on the graph, and if that vertical line crosses the graph exactly at one point, then it is a function. If it crosses more than once, then it is not a function. Okay, so we have a graph here. So we have this very first graph. Now we draw a vertical line. You can draw a vertical line anywhere. Okay, so if every vertical line crosses the graph exactly at one point, then it is a function. Now here, this first vertical line crosses the graph at one point. Okay, the second, it crosses the graph at one point. So every vertical line, it does not matter wherever you draw, it crosses exactly once. It means this graph is a function here. Okay, so this is a function. Okay, now second graph, we have the second graph and we do the same thing. We draw the vertical line. Okay, if you draw a vertical line, so you draw a vertical line, and when you draw a vertical line, if the vertical line crosses more than once, then it is not a function. Now here the vertical line crosses at this point. Okay, so at this point, 2 points, and here it crosses at 4 points, and this graph is not a function. Okay, not a function. And this is the vertical line test. You draw a vertical line, and every vertical line, okay, has to cross exactly at once to be a function. Now what do you think about C? Is C a function or not? Okay, now we can check it by drawing a vertical line. So you draw a vertical line, it crosses exactly at once, at one point, it means this is a function. Now what does it mean? Like why this is true? Like when the vertical line crosses exactly at one point and this is a function.
Because the x only has one value.
That's right. So to be a function, every x has to have exactly one y value. Okay. Now here, if you choose this x value, okay, so if you choose this x value, it only has this y value. Okay, one x value must have exactly one y value, then only it is a function. But in second graph, so when you choose this x value, it's y, it has a 2y value. Okay, so we have one y value here, and then we have two y values. One x can't have more than one to be a function. Okay, so that's the reason why the vertical line help us to check whether the graph is a function or not. Now here, if you choose your x to be 1, so if you choose your x to be a 0 here, 0, then it has a y value, 4 y values. This is one y value, this is the other, so we have 4 y values. So one x value has 4 y values. That means it is not a function. Okay, so to be a function, the vertical line has to cross the graph exactly at once. Okay, now the next here, So we need to check which of the following equation describe y as a function of x. Okay, so we need to check. So we have the equation here, and which describe y as a function of x. Okay, what do you think about the first ones? Now we can draw a graph here, okay, and from the graph also we can check whether it's a function or not. Now how do we graph? So let's solve for y. And what is the reason for solving for y? Y is our output, okay. So we have this equation 2x minus y equals to 1. So let's solve this equation for y. So we subtract 2x on both sides. So this cancel. We have negative y equals to 1 minus 2x. To get rid of negative, we multiply both sides by negative 1. So you multiply both sides by negative 1. And negative 1 times negative y, we have positive y equals to negative 1 times positive 1, negative 1 times negative 2x, positive 2x. So we have this function y equals to negative 1 plus 2x. Now is this this is the equation now. Now is this equation a function or not? That's what we need to tell. Is this a function or not? We can check by graphing, okay? Now let's graph. So we have x, we have y, and we get x, y point. Now can we choose any number for this x here? So can we choose any number as an input? Yes. If we get output, then yes, we can choose. Okay, let's choose x equals to 0. If x is equals to 0, what is our y? Negative 1. Okay, if let's choose x equals to 2. So if x is equals to 2, what is our y? 3. Okay, so we have 0, negative 1, 1 point, and 2, 3. So let's graph this. So this is x, this is y. So we have 0, negative 1. So 0, negative 1 is here. 2, 3. 2, 3 somewhere here, right? So we get a straight line. Now you draw a vertical line. You can. Now is this a function or not? What do you think? You draw a vertical line. It crosses the vertical line exactly at 1 point. So this is a function, right? This is a linear function. And you don't need to have a graph, but you can find this is a linear equation, and linear equation is a straight line, and every straight line is a function. Okay. Now, what about the second example? What do you think about the second example? Is this a function? It's not a linear function, right? Now let's check. Now we can use a graph. Now let's make a graph here. Okay. So we have x, we have y, x, y. Okay. Now can we choose? Now how do we solve here? Now what do we need to choose here? So we have this equation, absolute value of y equals to x. Do we need to choose y or x here? Now if you choose x equals to 0, what is y equals to? Okay, now let me choose x equals to 3. And how do we solve this one? So let's say we have x equals to 3. So we have absolute value of y equals to 3. How do we solve this? This is the absolute value equation. And how do we solve this? If we have absolute value equation, we always get a two solution. So here, how do we, in order to get rid of this absolute value sign, we have y equals to positive 3 or y equals to negative 3. So we have a 2y value for 1x value. Okay. Now the easiest way would be choosing a number for y and finding x. That would be easy for us. Okay. So if you choose y equals to 2, what is x equals to? 2. If y is 1, what is x? 1. If y is 0, what is x? So if y is negative 2, what is x? 2. And if our y is negative 1, what is x? 1, right? Now let's plot this. So we have 2, 2. We have 1, 1, 0, 0, 2, negative 2, and 1, negative 1. Now let's plot these points in a graph. So we have x-axis, we have y-axis, origin. So 2, 2. So this is 1, this is 2, this is 1, this is 2, this is negative 1, negative 2. Okay, 2, 2. So this is 2, 2. Okay, 1, 1. So this is 1 1 0 0. This is 0 0. 1 2 negative 2. 2 negative 2 is here. 1 negative 1 is here. Now you connect these 2 points. So we get this graph. Now what do you think? Is this a function or not? You draw a vertical line. And if you draw a vertical line, this crosses at 2 points. And this is not a function. Okay? Not function. So sometimes if you can't find from observation, then you can just draw a graph and use the vertical line test. What about the circle? So if we have we did a circle equation, right? Is the circle a function? No, right? We have a circle, and if you draw a vertical line, it crosses 2 points. So it is not a function. Okay. Do you have any question? Now, now I'm gonna just do the section 2.5 at the end. Okay. So we have like 2.6, 2.7 is still a function. So I want to talk function. Okay. So we'll do this 2.5 once we finish function topic. Okay. So let's go to the next section 2.6. But we'll do this 2.5 at the end. Okay, so here so in section 2.6 we will find whether the function is even function or odd function. So once we have a function, the function can be an even function can be an odd function. Okay, now we'll talk in detail